data integration into Amazon Redshift. For those of you who have been following the webinar series, you'll know Amazon Redshift is a petabyte scale data warehouse that's faster and simpler and less expensive than traditional warehousing solutions. And getting your data into Redshift is easy. I want to thank you for joining and let you know that whether your data is on-premise or in a cloud-based database like DynamoDB, you'll see how you can load your data into Redshift easily. We'll present a catalog of methods to load information. Some of the details on our best practices webinars, you'll see the details of this have been explored at length in the prior webinars. And you'll also have a chance to hear from one of our premier partners, Tunity. Tunity will show you their solution for moving data into Amazon Redshift. All right. So as I mentioned, there are a series of webinars here, and I just wanted to call your attention to the web reference for that. You can go to our site and get all of the database services webinars. The ones relevant to Redshift are, of course, the introduction and two of the best practices webinars that we put together with the help of our engineering team. We actually hear from two of the key contributors to Amazon Redshift to talk specifically about the best way to load data, how you choose your keys, how you handle workload migration, and space management within the database platform. And I encourage you to go out and have a look at those things once you've digested what we tell you today, and when you're trying to get optimal performance out of your warehouse on Redshift. So if we move on to our agenda, again this morning is fairly straightforward. I want to talk about the integration from Amazon S3, our object store. I want to talk about integration with DynamoDB, which is our NoSQL offering. And then we'll introduce a Tunity, and they can show you their solution as well. And we will leave some time at the end for your questions. All right, so to that end, the first thing that people will be concerned with is getting data into the Amazon cloud. This isn't something that's unique particularly to Redshift. This is one of the things, a bridge you cross when you start engaging with a cloud service. And Amazon provides a variety of ways for you to get your information into the cloud depending upon what you're trying to accomplish, the nature of the information you're moving, and what your time frames are. To start out with, there's a multi-part option where you're able to go and do faster, more flexible uploads into Amazon S3, which is the object store I mentioned earlier. You can upload a single object as a set of parts. This works particularly well with Redshift as our copy command that I'll tell you a little bit more about shortly allows you to load data in parallel into the cluster. Another option that you have is using our virtual private network. There's a facility within AWS that allows you to logically isolate sections of the cloud, of our cloud, where you can launch resources in a virtual network that you've defined. So you have complete control over your virtual network, the selection of your IP address range, selections and creations of subnets, and configurations of your routing tables and your network gateways. And this allows you to do quite a lot of customization, so you could even have a customer-facing subnet for your web servers and place your back-end systems in a private subnet so that there's no internet access. This allows you to operate as if what you have in the cloud is just an extension of your local network, and you would move data across the network in any way you say fit, really. Other options are Direct Connect. This allows you to move large amounts of information into S3 by establishing a dedicated network connection from your premise to AWS. With Direct Connect, you can establish private connectivity without you can connect directly from your premise into AWS using Direct Connect. The final option I'll talk about is the import-export ability that accelerates moving large amounts of data one time into AWS by using a portable storage device that's physically transported. You load the data up on your premise, move it to ship it to us, and we will load from there. Surprising, but you can get great bandwidth response out of this if you're moving data in truly massive scales. And what I want to draw your attention to here is that this is really just a graphical depiction of all the options that I've just described for you. You have the ability to do the import-export at the bottom of the page, moving data from your on-premise solution into Amazon S3. We'll do the copy for you. You just send us the media. You also go directly into S3 using the multi-part upload. which is quite convenient. And the other two options are a direct connection from your cloud-based networking to your premise-based networking. And you can use that using the VPN or the direct connect solution that I mentioned earlier. And if we could move on to the next slide, where I'll talk about some of the options that we provide from within Amazon to allow you to get data into Amazon Redshift. All right, and those are principally pulling data directly from DynamoDB, pulling data directly from Amazon S3, and then orchestrating data from one service to another within AWS or even outside of AWS using our data pipeline tool. All right. Slide. It's again my overview slide. I rely on this a lot, but it does really describe all that we're doing here. There is a command from within our SQL command set called copy, and copy has the syntax that allows you to pull information directly from DynamoDB. So if you have a table that you've defined within Redshift where you want data to age out of Dynamo, or you simply do a copy from there, and then that data will be available to you within Redshift, and you can perform your analytics there. So it's sort of how data moves through your systems. If you think about it, you have the ability to take data in very quickly. DynamoDB is very fast. It gives you completely predictable performance. It's seamlessly scalable, and you don't have to do any administration. You just dial in the scale, the performance you want, and you'll get it. Right, so you can stream data in there, massive scale, very fast, and when it's time to move that on and do some analysis, simply copy it into Redshift. I can show you what that means. It is literally copy the orders table in Redshift from the orders table in DynamoDB, and you pass your credentials, and you also pass this command here. And I don't want to get too deep into the technical details at all, but I want to call your attention to this right away. You give a read ratio there. Okay, you want to give some indication to Dynamo of how much attention you want paid to this particular command. You don't want to consume all of your capacity simply copying over to Dynamo. So again, loading data from Dynamo is easy. You use the copy command. It uses the massively parallel processing architecture of Redshift to read and load data in parallel from Dynamo. And the copy command is executed from whatever Postgres JDBC driver compatible SQL tool that you're running in. So if you use Navigator, you just connect with Navigator, execute the copy command, and you're set. You want to avoid in this copy command using excessive amounts of provisioned throughput, and so we recommend that you don't load your data from Amazon DynamoDB tables that are in production environment without using this command called read ratio. That lowers the percentage of unused provision throughput so that, for example, the read ratio 50 clause here will regulate the percentage of read capacity units within the customer table. All right, and we want you to pay particular attention to that so that you don't upset your normal operations. I do want to go on and just give you this brief overview. If you're pulling in information on web registrations and you want a sense of who it is that you've got registering and you want to reach out to various social media sources, say Twitter, Foursquare, Facebook, you can do that and pull that information into Dynamo using the mechanism we've just described and copy that over into Redshift pretty directly. And then the end-to-end solution, of course, you want to be able to push your results out somewhere, likely a reporting or a BI tool, and that's available to you again with a JDBC ODBC interface from Postgres, so you should have no trouble connecting the tool of your choice to Redshift. That's our DynamoDB story. It's a great way of moving data in at scale that you're collecting at high speed from a web interface, from a chat tool, from any kind of collection of sensors, those sorts of things. You can push information to Dynamo very quickly, and again, no administration, just the throughput you need. For S3, for textual data, for the most part, you pull information in either in volume with import-export. If you've got dozens of terabytes of data to move, that could be a very efficient way of doing things. If you're simply looking to move reasonably sized sets of data across the network, you can do that with S3. S3, with a multi-part upload, can break files up for you. The idea here being that you distribute the work across the full cluster of Amazon Redshift, so every compute node is doing the work of loading for you, and that minimizes, of course, the throughput because you're leveraging more the power of the system you're running on. So Here, the automatic or the upload from on-premise file is depicted in the screen in front of you here. Files are split into multiple pieces to facilitate the parallel processing. You're going to move data into the same region that your Redshift cluster exists in, and then when you do the copy command, multiple files will be moved in parallel into Redshift. And the idea here is, without getting into too much of the detail, that for every core that you're running within Redshift, you can be copying a file over. All right. For unstructured data, for say you're doing some work, you collect information through web logs or some other logging process, push that information into S3, and you can move that into EMR using a data pipeline. EMR is our Elastic MapReduce implementation. It's a way of running MapReduce or Hadoop within AWS, and you can do your exploratory analytics there. You can look at the data and look for trends or patterns or sentiment analysis or really any algorithm that you like. And then as you find things that are generally applicable, things that you want to be able to share out to a broader audience that, say, isn't necessarily skilled in programming but has a facility with SQL or knowledge of the BI infrastructure within your organization, the reporting tools, and is adept at getting at information in that way, push the data from EMR into S3 and then load that into Redshift. And that gives you the ability to take what you've discovered through your exploratory analytics and sort of make it operational data now. All right, and so this is a common pattern within AWS where once you've got the data from any source at all, really, if you push it into S3, you can pull it into Redshift pretty directly. All right, and now I want to pause with, I've covered the basic ways that you pull information into Redshift from within the tools that we're providing, and I want to talk a little bit about Tunity. Tunity is a premier partner of ours. They are folks who can show you exactly how their tool works in a very sophisticated and robust way to pull information into Redshift. So let me do that and shift control over to Brad.
Thank you, John. Very good. So I'd like to thank Amazon for featuring our solution today, and then, of course, thank all of those in attendance. My name is Brad Helliker, and I am Tunity's Director of Cloud Business. I am joined today by Riza Khan, our Director of Support Services. Together, Riza and I will demonstrate Tunity's Replicate solution for loading data to Amazon Redshift. So for those new to Tunity, our core competency is to deliver data quickly and easily. Why is this important? Because business users need answers to questions that drive their business. And corporations commonly invest millions of dollars in analytic environments to achieve a competitive advantage, but without the data, these systems cannot produce results. So organizations need timely access to all kinds of data, structured, semi-structured, and unstructured. And to meet this need, Tunity delivers virtually any data, anytime, anywhere with high performance, low total cost of ownership, and a quick time to value. Tunity enables enterprises to extract the value from big data analytics. So industry-wide, we hear of data warehousing discontent. As IDC points out, only 17% of organizations are very satisfied with the performance of their data warehouse loading process. The more traditional data warehouses cannot handle the data velocities and volumes that are commonplace today. So those familiar with transferring data across heterogeneous environments often discover these 5 challenges. Homegrown development requires precious IT resources, which are often limited, and at the same time costly. Native manual processes are certainly not real-time. Should updates take too long, information becomes stale, and a reduced value to the decision makers. Lastly, these scripted processes are extremely difficult to maintain. So given those challenges, Tunity's Replicate for Redshift is designed to allow organizations to overcome the data transfer bottleneck. At the same time, customers can avoid all that well-known heavy lifting. So with Tunity, your team can move more data in less time and with less cost. That is, Tunity simplifies and accelerates the process of data loading. So what is, by definition, Tunity's Cloud Beam for Amazon Redshift? By definition, Tunity's Cloud Beam is optimized as an end-to-end solution for accelerating data loading into Amazon Redshift. The Replicate solution provides for true automation, is easy to set up, and easy to manage. As you see here from this table, Tunity provides a variety of sources to manage both full load and incremental change data capture. So how does Replicate actually work? Let's first take a look at this common on-prem scenario. Carrying out automation, Replicate starts by managing the schema generation and data type mapping, looking at that source database. Replicate then intelligently auto-maps data types. Next, Replicate's transform filter then processes in memory and simultaneously bulk loads to the defined target database. Following the bulk load, Replicate looks to transaction logs and manages the incremental load of changes represented in source tables. Lastly, Replicate applies schema changes, such as DDLs, made to the source tables. So let's apply this to the world of Amazon and Redshift. Process-wise, it's very similar, of course. The Replicate server looks to the defined database, generates table files. From there, Replicate leverages Tunity's Cloud Beam service to send those files to S3. The S3 bucket is maintained by the end customer themselves. From there, Tunity Replicate validates the file content upon arrival. Once that's validated via an instruction channel, the Replicate server then executes a copy command to load the data tables from S3 into Redshift. From there, the Replicate server receives acknowledgement on a successful copy and apply. Now that's for full load. How does this look for incremental? Of course, it's the similar process, but once we receive confirmation, we then transition into the change data capture mode. From there, we're looking for differences. We move the net changes through a file, and then we execute the SQL commands merge change into data tables. So a lot of customers, given the urgency to load data, cite performance as most important when managing the loading process. So Replicate uses a proprietary transfer protocol designed to do several things outlined here. Specifically, the protocol leverages the Amazon multi-part transfers, allows for concurrent sessions and transfers, allows for compression, guarantees delivery by way of recoverability, and of course, encrypts the transfer. The outcome is performance gains of 10 to 12 times over standard copy. With that, I'd like to reintroduce Riza Khan, who will now demonstrate the Replicate solution and some sample jobs.
Thank you very much, Brad. I'm just going to go ahead and start my screen sharing here. Well, thank you, everyone, and thank you, Brad, for the introduction. We'd like to take a few minutes now to give you a brief overview of how a Tunity Cloud Beam can be leveraged for loading data from an Oracle data source into a Redshift target cluster. The same process also applies for all the other data sources that we support. However, today we'll simply focus on Oracle as a source. So in order to enable data loading using a Tunity Cloud Beam, a customer or a user must first enroll with one of the Tunity Cloud Beam services or subscribe to that service. And they would do that by coming to tunitycloudbeam.com. They would hit the Get Started link, and that takes them to a very simple sign-up form. Or if they're already a user, they can simply go ahead and log into the Tunity Cloud Beam portal. I'm going to log in with my own user account. And then once logged in, I'm able to see all of the services that the Tunity Cloud Beam supports. And today, specifically, we're going to be talking about the DB to Amazon Redshift replication. You can head over to the subscription section, see all of the services that you're currently subscribed to, and then hit the subscribe button to subscribe to a new service that's required. For loading the data into Amazon Redshift, you would need to subscribe to the DB to Amazon Redshift cluster, and that's it. That's all you need to do in order to enable the subscription of the service to load the data. After this, Tunity would provide you with the Tunity Replicate software, which you would then go ahead and install on on a server that's on-premise, that's close to the source database, and this allows you to begin defining your tasks for loading the data. So we'll begin by going to the Manage Databases and start out by creating my source and target database. So as mentioned, we're going to be using Oracle as a source. So I'll select from my drop-down Oracle and then define the connection string and the username and password that allows me to connect to that source. Successful connection being tested. And then I can go ahead and add my target, which is the Redshift cluster. So there's a few pieces of information that you need in order to load data into the Redshift. First of all, of course, you need the Redshift cluster information. And I've got a little cheat sheet here that has this information for me. I'll just go ahead and load that up. The port number, username, and password. And then I can select the database name that I'm going to be loading to, in this case, demo. The second piece of information is, of course, the Tunity Cloud Beam account that was subscribed to the DB to Redshift service. So I'll just go ahead and enter my credentials here. And then finally, we need an Amazon S3 staging bucket where the data would be stored temporarily before the copy command is issued against the Redshift cluster. And typically, this bucket has to be in the same region as the Amazon Redshift target. In this case, my Redshift target is in the Northern Virginia region, so I'm just simply going to use a demo Virginia bucket to temporarily store the data. Okay, so once I've gone ahead and entered all of this information, I can then simply click the Browse button here to select a folder that's on that S3 bucket, or I can go ahead and create a new folder to temporarily house the data. Once I hit Test here, it makes sure ensures that all of the information that I've provided is correct, and that completes my target definition. At this point, I can then go directly into my task creation. So I'll call this Oracle to Redshift. And then, as you can see, by default, full load and apply changes have been selected. So this means that we'll start out by doing a complete load of the data, and then we'll go ahead into apply changes mode. So if I click the OK button here, the interface or the design interface comes up, which allows me to then drag my Oracle source into the interface and the Redshift target. And then I can move straight into the table selection. As you can see, very easy in order to determine where we're going to get the source data from. We're going to use the HR schema, so I'll search there and select a few tables that I want to use, and then hit OK. And at this point, we're done. We're ready now to load data into the Redshift cluster. So I'll just save this and then hit the Run button. And as Tunity Replicate is designed with no scripting needed, it's a very easy process for click-to-load of data directly into a Redshift cluster. So what will happen is we'll see that we're going to prepare the target tables, then load data from the source tables into the target, and then continue to monitor the source for changes, and then update the target based on that, whether it's CDC for DDLs or DMLs. So click OK, and this starts up the task. We move directly into the monitoring interface, which shows us in real time all of the data that's going to be loaded from the source to the target. So we have now the 4 tables being queued up. We can see the estimated count of how many rows are going to be loaded. if I were to fire up SQL Workbench and connect to that Redshift cluster, I can then see that the HR schema has been created and all of the tables have already been loaded, including the columns being created. So automatically, this is handled for you based on how the source is defined. And then switching back here, we can click on the loading to see the progress of this data as it's being loaded. The throughput allows us to monitor how quickly this data is being loaded. And of course, depending on your bandwidth, you're able to load this data in the most efficient way possible by subscribing and using the Tunity Cloud Beam services. So as this is running, you have real-time data showing you the load of the duration of the load and how much or how many rows are actually loaded as part of this task. And as mentioned, the task will then go into actually CBC mode, waiting for changes to the source to happen. So we'll give this a couple of seconds to complete. Of course, as you go further along and you wanted to do some additional transformation of the data, such as renaming columns or adding additional columns, or doing things like transforming columns or values or data in some way, this is all supported within the Tunity Replicate interface. And you can even use existing schemas if you want to then load the data into an existing target table. And you can choose how you want to load the data, whether it's truncate the data first or adding the data to the target table as it exists. So with that, we can see that the full load has completed successfully. At this point, if I go to the target and open up the data, it will see that 107 rows have been added as part of the data loading or full load portion of Tunity Cloud Beam loading data into Redshift. So at this point, the task actually goes into change processing mode, and this means that we're going to be monitoring for any changes on the source database. So I have a little program that allows me to modify the source. So I can insert about 10,000 rows here simply by running this little app, and that allows me to show you that you'll see that the incoming changes will be queued up here in the number of transactions. By default, this app is set to auto-commit transactions on the source. Tunity Replicate recognizes that the transactions are being submitted, but will only commit them to the target if they were committed on the source. So once that source commit has completed, we will mark those or flag those for loading into the cloud. And we have a method of basically loading this data into memory and then performing or capturing those changes and creating those CDC files and then uploading them to the cloud and then performing the merge commands to load that data into Redshift. Again, the applied latency allows us to basically see how long this load is taking, as well as see the throughput here, so that I can quickly and easily monitor exactly what's happening with the data. And now you can see that 10,000 inserts were done and 10,000 updates as well. So going back to my target, if I run a quick count of the HR employees, we'll see now that we have the 10,107 rows added there. So this pretty much completes what I wanted to share with you today in terms of an overall overview, a quick demo overview of how you can use Tunity Replicate to load data very quickly and efficiently into Amazon Redshift. At this point, I would like to transition back over to Brad.
Thank you, Riza. So for those looking to overcome the data transfer bottleneck, we welcome you to engage with us and take a closer look at the Tunity Cloud Beam solution set. Together we can help you move more data in less time and with less costs. So for more information, we invite you to visit us at tunitycloudbeam.com. I otherwise welcome an email or a direct call and would be pleased to assist you with resources. Of course, in a webinar, we keep things high level, but if you have a project with details that you'd like to discuss, we're happy to help you along. With that, I'd like to pass it along back to John.
Thank you, Brad, and thank you, Riza. What I'd like to do now is really reach the point where we can open the floor up to questions. So if you have questions, go ahead and use the interface to ask them, and we will address those. There are a couple already out there. Apparently my sound cut out, as I was afraid it might. When I was talking about read ratio on the DynamoDB tables, on the copy command, I want you to be deliberate here when you're going out and you're going to copy from DynamoDB, particularly if you're setting up Redshift and you're just experimenting with it. Don't go to your production tables and just pull all the data down, because you can be throttling your ordinary operations. So instead, consider using this read ratio and set it to something that's lower than the average of the unused provision throughput, and you should be okay and get by without creating a bottleneck for yourself. That was the point I was trying to make. Let's see, another question that we've got is, can you move data from SimpleDB to Redshift? And you certainly can, and the way you do that is to unload from SimpleDB to S3 and then move data in from S3 to Redshift, as described earlier in. Let's see. I have a question. Is the S3 bucket in the middle between the on-prem database and Redshift required? What we're talking about is loading data into S3 and then copying the data from S3 into Redshift. So yes, that the stop at S3 is required, and that is repeated 2 or 3 times. We've got another question in here. We've had some issues moving Unicode data from on-site SQL Server to Redshift. And they want to understand, does the Tunity handle data conversion issues? And in particular, they're talking about Unicode data. So I'll open that up to either Brad or Riza if you'd like to take that on.
Sure, Brad here. Thank you for passing that along. We're happy to engage with that specific, with the person who offered that question to better understand the source there, and we should be able to solve that for that person.
Terrific, thank you. All right, a question here. I'm interested in completely transforming or reorganizing the structure of our source database while inserting into Redshift in order to obscure some of the complexities in our system for reporting purposes. How can we do that with Tunity?
Hi, Brad here again. We just, that is something that's a common request. We do have experience in working through those solutions for customers. That is, depending on the specific example, we, like the other customer, we welcome the opportunity to take a closer look at what your objectives are and find a model for you.
Okay, I have another question here. Will it handle large changes during a batch window? That's a little vague. For example, 1 terabyte of archive log change in an Exadata database generated within an hour. If you're talking about can we ingest a terabyte of data, that would be dependent upon your the size of your cluster and how it's organized. But certainly engage with your account team. We'd be happy to address that with you. I have another question here. What about relational databases like RDS Oracle? Not sure what the question is here. If you're asking, can we move data from a relational database like Oracle, certainly we can do that, and I think you've seen an example of that from Tunity, and you can certainly push data from Oracle to flat files loaded into S3 and copy them in from there as well. Let's see. All right, and if you've got further questions, please get them in there. Otherwise, we'll give another moment. And is there an AWS-only recommended solution to move data from RDS to Redshift and keep Redshift up to date? For all these terms, what does up to date really mean? If you want to completely keep your database up to sync and do complicated change data capture logic, this is a fine opportunity for our Tunity or for people who do that. You could create systems on your own and host them certainly in AWS, but there is no one. There's no ETL process per se that's going to handle that for you as a service within AWS. And Brad, do you want to comment on that?
Yes, thank you, John. To go from RDS to Redshift, we do have a solution in place. It is have to look at the specifics of the change state capture function. We do indeed support full load.
All right, and we have a question here about, say, for example, that you're running SQL Server on an EC2 instance. The question is, what built-in command does one use to copy a file from the EC2 instance to an S3 bucket? And that's certainly, well within the range of our solution architects, and I would encourage you to get in touch with your account team to help you with questions of that kind. All right, and with that, we've exhausted our list of questions. I'd like to thank you for attending this morning and urge you to go and take a look at our best practices webinars that are listed on the URL in front of you. You should be able to go and see slides for this, the corrected presentation itself, as well as prior webinars that were presented, the best practices and the overview. Once again, thank you for your attendance, and thank you for Tunity for working with us to present this.